So the other day I went to use my label machine and it was dead. However, fortunately it also runs off a DC power supply rated between 7 to 9 volts, and I happen to have a bunch of these lying around the house, mainly rated at 5 volts, but let me show you this one. So you can, hopefully you can see that there. That has an output rating of 7 volts. So I thought, hey presto, that should do the trick, but to no avail. And it was only upon closer inspection that I noticed that it's actually rated 7 volts AC, not DC. Now, why I've got a 7 volt AC supply in the house in the first place, no idea. If anybody knows what a 7 volt AC supply is used for, please let me know in the comments below. However, this 7 volt AC power supply could be used to help to explain the difference between AC and DC in a very visual way. So I'm going to do a short experiment, and I promise you, even if you knew nothing at all about the difference between AC and DC before, you will definitely be able to see the difference after watching this experiment. And also it happens to coincide nicely with the release of the new Tesla movie, The Godfather of AC. So stick around and hopefully you'll enjoy. So to begin with, I'm going to do a quick demo on how electricity is created. So inside a standard DC motor, you'll see a coil of wires attached to a rotor arm, and inside the housing of the motor there will be some magnets. So what's interesting about a motor is it also contains all of the components required to make a basic generator. I'll just show you the motor spinning using a 1.5 volt power supply. So I'll stick a couple of croc clips across both terminals, and just to make it easier to visualize, I'll stick a prop on the end. So this is the conventional way that a motor works. However, if we were to reverse engineer this process by connecting a drill to the shaft of the motor and the terminals across a multimeter, you will observe that we can actually generate electricity, in this case about 0.17 of a volt. But this is essentially how electricity is delivered to your home. The only difference being the generator will be on a much grander scale and probably using a steam turbine as opposed to a drill. So for this demonstration, I'll be using the 7 volt AC supply on the left and a 7 volt DC supply on the right. So I'll just show you the actual voltages reading across a multimeter. So you can see that's reading 7.91 DC. And the AC transformer, you can see that's reading 7.96 AC. So I'm going to switch over to the oscilloscope setting of the meter now, and we will look at the frequency of the AC and DC supplies. Now, to make things a little easier, I've drawn a green line across the 0 setting of the display, and this acts as a demarcation of the positive and negative side. And you can see that the DC supply is just a straight line within the positive side of the graph. Now let's switch to the AC supply, and straight away you can see we're getting that classic sinusoidal wave, which is switching from the positive to negative side of the graph, hence the reason why it's known as alternating currents. To give you an idea of how those oscilloscope readings impact things in the real world, I've rigged up a couple of LEDs, one connected to the AC supply and one connected to the DC supply. So I'll show you that there's no trickery going on here. So that's the DC supply reading 7.82 volts, and we'll just switch over to the AC supply. And I have to move this over to the AC setting. And you can see that's reading about 7.2 volts AC. But here's the really interesting thing. If you were to play back the footage in slow motion, you'll notice that the AC bulb is flickering whilst the DC bulb remains stable. So why is this? Well, if we think back to our oscilloscope graph, you remember that the alternating current was moving from positive to negative, positive, negative, 50 times a second. Now, in order to move from positive to negative, it has to intersect the 0 point, which is when the bulb will switch off. And that's exactly what we're seeing. The current moving from positive to the 0 point, off, and then to negative. And that's the difference between AC and DC. Hope you found this useful.